So this video is on our next reaction of lipids called hydrolysis. So if condensation makes lipids, makes fats plus water, condensation's how we took fatty acids and added them to a glycerol backbone and got a fat plus water or triglyceride plus water. Hydrolysis is just the opposite. Hydrolysis is taking your triglyceride and breaking it down. So here, we're going to take our triglyceride, our triacylglycerol, and we're going to react it with water. Here we've got water and lipase. So lipase would be an enzyme. We need something to catalyze the hydrolysis of our lipids. So we'll take an enzyme and then we'll end up with glycerol and 3 different fatty acid molecules. And so if our triglyceride has 3 different fatty acid chains, if they are R and R prime and R double prime, we'll end up with 3 different fatty acids. One that has an R on it, one with an R prime, and one with an R double prime. Okay, so again, our triacylglycerol's got this CH2CH backbone, like glycerol. It's got O, C double bond O, and R. It's got O, C double bond O, and R prime on the next carbon. And on the third one in glycerol, O, C double bond O, R double prime. So what are we doing here? Well, we're going to look for that ester linkage and we're going to break it. Break the C to O that comes before the double bond O. Break the C to O so that the oxygens all kind of stay with the glycerol backbone and the C double bond O's all sort of stay with the 3 fatty acids, if you will. And again, R and R prime and R double prime, those are just 3 different like carbon chain links. They could be saturated versus unsaturated, but 3 different, fatty acids. So they could have different carbon lengths or be saturated versus unsaturated. But it just means that you have carbon chains there of varying lengths or degrees of unsaturation. Okay, so what's going to happen here? Let's do an example. We have tristerin. So this is a glycerol of stearic acid. So we've got CH2 is our backbone. Then we've got O, C double bond O, CH2, 16, CH3, and we've got that side chain repeated 3 times. The O to C to double bond O, bonded to CH2, 16 of them, and CH3. So again, we're going to break the O to C bond in the chain, that ester linkage. That's what we're looking for to break that. We're going to need a catalyst. Here we've got an acid catalyst. So we're using an acid rather than an enzyme in biological systems. We're going to be more likely to use an enzyme. Here we've got H2SO4 as an acid catalyst. We're going to add 3 waters. So we're going to need 1 water for each fatty acid of the triglyceride. And then we're going to end up with our glycerol backbone because waters, H's, are going to add onto that. And then we're going to end up with 3 stearic acids or 3 OHs. So, if you think of the water, each water gets broken into H adding onto one side and OH adding on to the other. So H adding to glycerol, OH adding to the fatty acid, H adding to the glycerol, OH adding to the fatty acid. So I think that covers our example here. Let's get into real examples where we need to predict the products. So let's recognize that we have a triglyceride here. How would we recognize that? Or triacylglycerol. We see our glycerol backbone, CH2, CH, CH2. It's connected by ester groups to side chains. The ester groups are O, C double bond O. The side chains are CH2, 16, CH3, CH2, 14, CH3. Those are both saturated. And then we've got CH2 7, CH double bonded to CH, CH2 5, and CH3. So that's an unsaturated side chain. We're going to add 3 water molecules, and then we've got pancreatin, a lipase, so an enzyme. So there's our enzyme catalyst. And so what's going to happen? Well, we want to recognize that that water, is really a message to us that hydrolysis is going to occur. So think of water as a beep, beep, beep message that you've got hydrolysis. Think hydration. You've got this water meant to add across the molecule. So what are our products going to be? Well, we're going to get our glycerol backbone back. So that's CH2, CH, CH2, where each carbon has an OH on it. So we're going to reform our glycerol backbone. Oops, so we're going to get glycerol. And then in this case, we're going to get 3 different fatty acids. So let's write them each differently, or separately rather. Let's write HOC double bond O. And then the first one, we're just copying it, CH2, 16, and then CH3. And then the next one is HOC double bond O. And then the next one had CH2, 14, and CH3. And then the last one is HOC double bond O, CH2, 7. And then there was a CH double bonded to a CH, and then CH2, 5, and I'm running out of space, but there should be one last CH3 on there. I ran out of space for that guy. I tried to leave myself a lot of space for this problem. I just ran out of space for that last CH3 of that last fatty acid. But anyway, it's copied right from this one. So we copy the side chains. We copy the R prime, the R double prime. And, really we're just having to make sure that we put our alcohol groups back on our glycerol backbone, that we, make ester functional groups for, carboxylic acid. Like our ester functional groups change to carboxylic acid. So here, of course, in our triglyceride, we had ester groups, and we have to draw carboxylic acids because, of course, we have fatty acids. Yeah, so our fatty acids have to have our carboxylic acid. So we get our glycerol backbone when we're done with this, plus 3 fatty acids, which of course have our carboxylic acid functional group in those fatty acids. Okay, we've got one more example of hydrolysis. So again, how do we recognize that it's hydrolysis? Well, we see that we're adding water. We see we've got H+, so we've got some acid catalyst. It's going to be an acid, oh my gosh, catalyst. Sorry about that. We've got our acid catalyst if we're doing this, maybe in a chem lab. We've got our enzymes in a biological system. Okay, so we recognize that this is hydrolysis of a triglyceride because we see these 3 long chains coming off of a glycerol backbone. And the glycerol backbones are CH2, CH, CH2. It's got 3 ester groups. And then those ester groups look like they're followed all by the same chain. Let's count that chain. It looks like in the CH2 section, there's 1, 2, 3, 4, 5, 6, 7 CH2s. Then there's a CH double bonded to a CH. Then there's 1, 2, 3, 4, 5 CH2s before the CH3 on the end. Okay, so that's going to be kind of helpful. So we're going to make our glycerol backbone because, of course, we're going to break these ester linkages, and we're going to get our glycerol backbone. CH2, OH, CH2, OH. Oopsie, that one should just be CH. and CH2OH. So we get our glycerol backbone. And then here we can write that we just get 3 of the same fatty acid side chains. So let's do HOC double bond O for carboxylic acid. Then let's do CH2, and we counted that there were 7 of those. Then it was going to be CH double bonded to CH. And then we counted that there were going to be 5 CH2s followed by CH3. So we've got our glycerol, and then we've got our 3 fatty acids. In this case, they're matching because we had this simple triglyceride, right? We recognize that this was a simple, triglyceride or triacylglycerol. Okay, so hydrolysis, we see fat, we see water. We recognize that we're probably breaking that ester linkage. We're going to end up with our glycerol backbone and our 3 fatty acid chains. They might be matching, or they might be all 3 different. And sometimes we're using an enzyme catalyst. Sometimes we're using acid as a catalyst as well.